This is Sparks Sustainability, and I'm Eric Sparks. In the first years of World War II, the United States was very isolationist and remained principally a peacetime economy. They did start finally selling some munitions, vehicles, and supplies to the Allies, but the vast majority of manufacturing was still regular peacetime manufacturing. After the attack on Pearl Harbor, in a matter of mere months, the vast industrial capacity of the U.S. was retooled and pivoted to wartime manufacturing. By the end of the war, the U.S. production of military equipment was equal to the entire rest of the world combined, both Axis and Allies. That transition is one of the most dramatic examples of extremely rapid, large-scale industrial transformations. There was immense public support, political will, and government backing. The government ensured that there were large amounts of money to be made in virtually all areas of production, and so the transition happened rapidly and smoothly. In the past few decades, the industrial transformations of first China and then India have been obviously far slower, but just as dramatic. As dramatic as those transformations have been, the current industrial challenge facing us today is far greater than any of them. Because it's not just a change of what we make or how much, it's a change of how we make things, how we design things, how we use things, what happens to those things when we are done with them, and how we even think about the stuff we make and buy. What is that challenge? Moving the world from its current linear economies to circular economies. Right now, we mine or harvest virgin materials from the far corners of the world. Those materials are shipped long distances to facilities to be smelted and refined or processed, shipped somewhere else to be made into sheets or blocks or whatever other processing they require, and then shipped again to be manufactured into a product that is likely then shipped elsewhere to be incorporated into another product, and then shipped a long way to a store or a warehouse, and then travels to the end customer. We use that thing for a short or long time, and then in general that thing gets thrown in the trash and goes to a big hole in the ground forever. In a circular economy, we find ways to keep using things as long as possible, whether by repairing, refurbishing, reselling, leasing, or whatever. And only once there is no way we can possibly use that thing anymore, do we then take it, disassemble it into the different materials, and then reuse those materials to make other things, instead of just throwing them away. So why can't we do that right now? There are some things that it is very difficult to reuse. Some things are very difficult to repair. There are some things that are very difficult to disassemble in order to reuse the materials. There are some things that might be okay to reuse, but there simply are no methods nor infrastructure in place to do so. There are some things that might be difficult to reuse or recycle because of biohazards. Almost everything we make needs redesign to be more reusable, last longer, easier to disassemble, perhaps made of completely different types of materials, easier to recycle. Perhaps even how that need is fulfilled, completely rethought and done in some totally different way. How can we meet this challenge? It is definitely possible, but there are many different innovations that need to happen. New feats of engineering, process design, infrastructure design, and more will need to be developed, many thousands of them. It will likely even take new feats of marketing to change how consumers view particular types of products and how they interact with them. How can we get as much innovation and invention happening in as many different fields, sectors, and disciplines as possible? To me, one possible answer, or at least inspiration, comes from the first decades of the 20th century. In those decades, aviation was in its infancy, and many who saw its potential wanted to help speed its advance. How did they do that? By offering large prizes for particular aviation firsts. By 1929, over 50 large prizes had been offered. some by businesses, some by individuals, and some by governments. The most well-known was called the Orteig Prize, which was $25,000 for the first non-stop New York to Paris flight. While you may not recognize the name of the prize now, the winner, Charles Lindbergh, in his plane, the Spirit of St. Louis, became a household name worldwide. These prizes were much sought after, and generally the teams competing invested far more than the prizes were worth. Russian-American aviation pioneer Igor Sikorsky reportedly personally spent over $100,000 on his team's attempt. Why? Why would he do that? Because it wasn't about the prize money, but first, the bragging rights and industry prestige of winning, and second, the business opportunities and contracts that might come to the winner could be worth vastly more than the amount of the offered prize money. Also, the innovations that were developed may not have won one of the prizes, but they still ended up being valuable innovations for the companies who made them and for the industry as a whole. Currently, grants and subsidies and contracts are given to companies to develop something. When you give a grant to a company, then one company is going to spend that money provided to them and maybe a little more of their own money to develop that thing, which it's good, but the amount of innovation is relatively limited and mostly limited to the company who won the grant and possibly a couple others who tried to win the grant. However, when a large prize is offered instead, many companies and individuals will invest vastly more money to win the prize than the prize is worth. If they win the prize, then large amounts of business could come their way. Even if they don't win, they still might come up with innovations and inventions that could drive and grow their business and even open new markets. Offering open prizes that anyone can compete for could be one of the best ways to get the most innovation for the money. We have an incredible transition to make that will require amazing amounts of innovation. Offering prizes could be an incredible way to promote and stimulate the innovations in products and processes that are needed. So what kinds of things could we offer prizes for? How about things that are impossible or difficult to recycle right now? Things that can't be reused? How about prizes for designing products which last far longer, are far easier to repair, and far easier to disassemble at the end of their usable life, so the components can be reused or recycled? There could be prizes for new manufacturing methods that are far more energy efficient or generate far less waste materials. There could be prizes offered for methods of carbon capture and storage. Perhaps a method of carbon capture that can result in a limestone-like material that could be used in cement and concrete production, do carbon capture, and decarbonize the construction industry at the same time. Perhaps a simple and efficient method of producing biochar that can be installed widely throughout agricultural areas to sequester carbon and improve soil health and water retention. Perhaps entirely new business models for products or industries that would facilitate circularity. Perhaps new frameworks for policies or methods for preserving biodiversity. Some near-term prizes might be for very specific needs, but longer-term prizes could be left wide open to allow as much freedom as possible to fulfill the need. A near-term goal might be for a specific type of electric bus for urban public transportation, while a longer-term goal might simply be about revamping urban public transportation in general to make it more efficient. In the second goal, the innovation might come up with something completely different than buses or trains or anything we currently use. Let the innovators innovate. Perhaps some of the prizes could have multiple awards, different amounts for first, second, and third place. The big goal is to get as much innovation going as possible, while giving the innovators as much freedom as possible to come up with creative, novel solutions. This overall challenge of moving to a circular economy powered by renewable energy really has the potential to drastically push many different economies forward into new eras of change and growth. Economic growth will no longer be limited to countries which can get reliable access to fossil fuels or who can mine or import large amounts of raw materials. Any country which has an incoming stream of products will have an incoming stream of raw materials. And any country that has access to sun, wind, or moving water will be able to power industries that can process those products back into raw materials and then into new products again. We humans are capable of amazing things, and this challenge, while great, is certainly not beyond us. If we spur our ingenuity, we can accomplish amazing things, and we can enable great transformations. If we offer large prizes for the innovations that need to happen, then someone will figure out how to make it happen. We have over 8 billion people on this planet. How many Newtons, Edisons, Einsteins, Teslas, Westinghouses, Faradays, and Da Vincis are out there waiting to rise to the challenge? Thanks for listening. I'm Eric Sparks. For more info or to contact me or for a text version of this article, visit sparksustainability.com.